everyone. So today we will continue to talk about data structures. So today our topic is tree. Okay, so first, what is a tree? A tree is a data structure, and it is a hierarchical structure that is used to represent and organize data in a way that is easy to navigate and search. It is a collection of nodes that are connected by edges and has a hierarchical relationship between the nodes. The topmost node of the tree is called the root, and the nodes below it are called the child nodes or children. Okay, each node can have multiple child nodes, and these child nodes can also have their own child nodes, forming a recursive structure. Okay, and these are the basic terminologies in tree data structure. So now we will talk about parent, child, root, leaf, and level and subtree. So now we'll use this picture to illustrate the tree data structure. So first, the root. The top of the tree data structure is called the root. So this one, A, is the root of the tree. And in a relationship between two nodes, the node on the top is called a parent, and the node that is under this node is called the child of this node, and they must be connected to form this parent and child relationship. And so, for example, this group of nodes is called a subtree of this tree. And now we talk about the level of the tree. So the level of the root is 0, and the level of the tree is the count of edges on the path from the root node to that node. Okay. So for example, this level of nodes have level 1, and this level of nodes have level 4. And these kind of nodes that have no child nodes are called the leaves of the node. So they are not necessarily on the last level of the tree. So for example, you can look at the node G. It has no children, so it is also a leaf node. This graph illustrates the subtree. So we can see that any node of the tree along with its descendant is called a subtree. Now we'll talk about tree traversal strategies. So basically there are 3 commonly used traversal techniques when you traverse a tree. So they are pre-order, in-order, and post-order. So we'll use this tree to demonstrate different traversal techniques. So the first is pre-order traversal. So you visit the root first, and then you visit its left subtree, and then you visit its right subtree. So we can look at this tree. So first you visit the root of the tree. So you'll get 1. And then you visit its left subtree. So you will visit this subtree. So inside this subtree, it is also first pre-ordered traversal. So you also visit the root of this subtree, so you will get 2, and then you will get 4, because it is the left subtree. And then you know that it is a leaf node, and then you will go back to this node and visit its right subtree, so you'll get 5. So you will get this order. So 1, 2, 4, 5, and then you go back to 1 and visit its right subtree. So you will visit this one. So you will get 6, 3, 6 root left subtree and right subtree. So you get 3, 6, and 7. So this order is 1, 2, 4, 5, 3, 6, 7. Okay. Now we'll talk about in-order traversal. So in this kind of strategy, you first visit its left subtree, and then you visit the root, and at last you visit its right subtree. So in this tree, you'll find that this is a root, so you visit this left subtree first, and then inside this you visit 4 first, and then you visit the root that is 2, and then you get 5. So you finish this subtree now, and then you go back to the root because it is the second step, and then you visit this subtree, so you get 6, 3, and 7. Okay. So in this in-order traversal technique, you'll get 4, 2, 5, 1, and then 6, 3, 7. Okay. So the next strategy is called post-order strategy. So in this strategy, you visit the left subtree first, and then the right subtree, and at last you visit the root. So in this kind of strategy, you also get 4 first, and then you get to 5 because it is the right subtree of this subtree. And then you visit 2 because it is the root of this subtree. So then you finish this subtree and you get to another subtree. It is the right subtree of this whole tree. And then you inside this tree also get 6, 7, and then 3. And after visiting these 2 subtrees, you will get back to the root of this subtree, so it is 1. So in the post-order traversal, you will get 4, 5, 2, and then 6, 7, 3, and last 1. So next we'll talk about a sometimes used traversal techniques. It is called level order traversing. So for each node, first the node is visited, and then its child nodes are put in a FIFO So we talked about queue last time, and then again we visit the first node. Again, the first node is popped out, and then its child nodes are put in a FIFO and repeat, and the queue becomes empty. So you can use this algorithm to get a level order traversal of those trees. So you'll get 1, and then 2, 3, and 4, 5. So now we are talking about why we use or implement this tree data structure. So unlike array and linked list, which are linear data structures, a tree is a hierarchical or non-linear data structure. So these kind of trees are used in file systems, for example, in a computer, or the organizational chart in a company. So you can look at this picture. So it shows a file system that implements a tree data structure. Okay. The tree structure allows for a natural representation of parent-child relationships. For example, if you have a file called user, and then you know that home belongs to user, so it will be the child of the user, and you will know all these nodes that you can get through a path from user to this, and it will be very easy if you implement a tree to get this kind of relationship between these files. Okay. And trees are also used in sorting because, for example, in a self-balancing binary search tree, the data is automatically sorted as it is inserted into the tree, making it easy to find the minimum, maximum, and other values in the tree. So in sorting, probably later when we talk about sorting algorithms, we'll also sometimes use trees. Okay. So now we are talking about a special type of tree. It is binary tree. So a binary tree is a tree data structure in which each node can have at most 2 children, which are referred to as the left child and the right child. So this is a graph of a binary tree. So you can see that it can have a node can have at most 2 children. For example, the node 1, it is a root and it had 2 children, 2 and 3. So we will talk about some special properties of binary trees. So first, the maximum number of nodes at level 1 of binary tree is at level L of a binary tree is 2L. So because one node can only has 2 children, so at each level it can only has at most 2L nodes. Okay, that is very easy to understand. So second one, the maximum number of nodes in a binary tree of height h is 2h minus 1. So for example, this level is node 1 has height 1, so its maximum node number is 2 times 1 minus 1 and then this one. The third one, a binary tree with L leaves has at least log L in base 2 plus 1 levels. And the last one is in a binary tree where every node has 0 or 2 children, the number of leaf nodes is always 1 more than the nodes with 2 children. Okay, so now we finished talking about binary trees, and I want to make sure that you all understand, especially the traversal techniques that we talked about today. So these are very important. So probably I'll give you another example to make sure that you understand. Okay. Okay. So suppose we have a tree in this structure. So if we want to traverse this tree in, for example, pre-order traversal, so what will we get? What we can answer this question.
Can I repeat the question?
So if you want to traverse this tree in using a pre-order technique, so what number sequence will we get?
I don't know. Ask him.
So I can give you some hints. So when you use pre-order traversal technique, you visit the root first, then you visit the left subtree, and then you visit the right subtree. You can think about this. You visit the root first, and then left subtree, and then right subtree.
1, 2, 5, 4, 3, 6.
Right. Yeah, it is correct. And then if you want to visit a tree, for example, in post-order technique, so what will you get? So you visit the left subtree first, and then right subtree, and then you get to the node root of this tree.
5, 4, 2, 6, 3, 1.
Yeah, correct. So it seems that you all understand the traversal techniques of traversing trees. So I think that's all for today's club activity. So thank you for listening.